Hello everyone. In this question, it is given that if beta plus cos square alpha and beta plus sine square alpha be the roots of x square plus 2 small bx plus small c equal to 0 and gamma plus cos to the power 4 alpha and gamma plus sine to the power 4 alpha be the roots of x square plus 2 capital bx plus capital c equal to 0, then we have to find the relation between the four parameters small b capital B and small c capital C. Okay, we have to find an equation containing these four parameters. Okay, so first of all, we are given two quadratic equations, right? The first equation is x square plus 2 small bx plus c equal to 0, and this has roots beta plus cos square alpha and beta plus sine square alpha. Okay, and the other equation is x square plus 2 capital Bx plus capital C equal to 0, which has roots gamma plus cos to the power 4 alpha and gamma plus sine to the power 4 alpha. Okay, so the powers are different in among the roots in either equation. Okay, also there is nothing said about alpha beta gamma. So if we try to solve these equations individually, okay, in the first equation, if we do the sum of roots, okay, sum of roots beta plus cos square alpha plus beta plus sine square alpha, okay, this is equal to the negative of coefficient of x upon coefficient of x square, so this will be equal to minus 2b upon 1. Okay, so if we simplify here, on opening the bracket, this will give us 2 beta and cos square alpha plus sine square alpha will give us 1. So this becomes 2 beta plus 1 is equal to minus 2b. Okay, and if we try the same approach in the second equation, if we do the sum of roots, we see that we get gamma plus cos to the power 4 alpha plus gamma plus sine to the power 4 alpha will be similarly equal to negative of minus 2 capital B, right? So in this case, however, we can't simplify this cos to the power 4 alpha plus sine to the power 4 alpha, right? In simple terms, we need extra terms. So there is no point in trying to simplify this one, in my opinion. Okay, so this just becomes 2 gamma plus cos to the power 4 alpha plus sine to the power 4 alpha is equal to minus 2 capital B. Okay, so now if we look at the this is sum of roots, right? If we look at the product of roots, if we look at the product of root, this was the sum of roots. Okay, now if we look at the product of roots, so we have the roots beta plus cos square alpha times beta plus sine square alpha in the first equation will be equal to the constant term upon coefficient of x square, so this will be equal to small c. Again, if we simplify this, there is nothing much helpful here. Okay, on simplifying, this will just become beta square plus sine square alpha beta plus cos square alpha beta and then cos square alpha sine square alpha. Okay, so I'm not writing the other one here, you can write it and try. Let us now look at the difference of roots. Okay, if we look at the difference of roots between this pair, we see that beta and beta will cancel out. Similarly, the difference of roots in the second equation, the gamma and gamma will cancel out. Okay, so we, instead of doing the sum of roots and product of roots, let us look at the difference of roots. Okay, so difference of roots will be beta plus cos square alpha minus beta plus sine square alpha. This will be equal to the square root of the determinant of the first equation upon the modulus of coefficient of x square. Okay, so the modulus of coefficient of x square, here the coefficient of x square is 1. Okay, so the modulus and the normal value are identical. Okay, so basically this formula is square root of delta upon mod a. Okay, so here the beta will cancel each other and this becomes cos square alpha minus sine square alpha, right? So this is nothing but cos 2 alpha, which will be equal to square root of the discriminant in the first case will be b square is 2b whole square, right? So this becomes 4b square 2b whole square minus 4ac. Now a is 1 here and c is small c, so this becomes minus 4c. Okay, so on simplifying, this becomes, if we take the 4 outside, this becomes 2 times square root b square minus c. Okay, similarly for the second equation, we have gamma plus cos to the power 4 alpha minus gamma plus sine to the power 4 alpha. This will be equal to the discriminant of the second equation again upon the absolute value of the coefficient of x square in the second case. Okay, this is also positive one, so there is no need to write this absolute value, but in general we need the absolute value. Okay, so this gamma will cancel each other. Now we are left with cos to the power 4 alpha minus sine to the power 4 alpha, right? So we can write it as cos square alpha whole square minus sine square alpha whole square, right? A square minus b square, we can write it like this, right? So this now gives us, in the second equation here, the discriminant will be again 2 capital B whole square minus 4 1 times capital C. Okay, so the structure will be same as the previous one, right? The only differences are in the like the parameters here. It is small b and capital B and small c and capital C, right? Everything else, the signs are same. So this will be 4 capital B square minus 4 times capital C. So this becomes 2 times B square minus capital C under root. So if we do the a square minus b square from the here, this will give us cos square alpha minus sine square alpha times cos square alpha plus sine square alpha. Okay, so this is equal to 2 times square root b square minus c. So this is again cos 2 alpha and this is 1, right? So this becomes cos 2 alpha is equal to 2 times square root capital B square minus c. Now again we had this equation, right? Cos 2 alpha was this equation from the first quadratic equation, right? We had this cos 2 alpha is equal to 2 times square root of small b square minus c. So we can use this here. So using this becomes 2 times square root b square minus small c is equal to 2 times square root b square minus capital B square minus capital C. Okay, this is from using equation 1. So now we can just cancel this 2 and we square both sides. So we get b small b square minus c is equal to capital B square minus capital C. So if we take all the b's to the one side and c's to the other side, this becomes b square small b square minus capital B square is equal to small c minus capital C. Okay, so this is the required relation. This was given in the among the 4 options. Okay, I did not give the options in the original question here because there are, like, it will take more space here. Okay, so I wrote the question like this, but this was one of the options. The other options were like b cube minus, like basically it was given cube here, one was given b minus b equal to c square minus c square, like that. Okay, so this is the required answer. Okay, here you see that doing the sum and product of roots does not help, but difference of roots is very beneficial here. Okay, since the roots are of this form, if you do the difference of roots in either case, they simplify in very few steps. Okay, so this is the best method I know for this question. Okay, so this is the required answer, and if there is any doubt in any step, you can highlight, okay, in the comments. Otherwise, this is finished, and thank you for watching.